All right, here we are. The last section of this unit is 7.6. And what we are working on today is to use factoring, which is what we've been working on the whole unit, to make predictions with quadratic models. All right, so like I mentioned, typically in class, I would just hand out this worksheet and just encourage students to work together in groups to try to figure it out. So hopefully you had a chance to do that. If not, maybe stop the video and give yourself 20 to 30 minutes to really try to dig deep into both of these problems, okay? So there's this problem number 6 about the throwing the ball into the air. And then on the next page, there's a question number 10 about a garden and an area and that kind of stuff, okay? So really try to give them your best shot. All right, so hopefully you did that. Let's take a look. So for part A, let's just read the beginning part first. So it says a person throws a ball into the air. The height in feet of the ball after t seconds is given by the equation h equals negative 16t squared plus 80t plus 4. Okay, so they gave you that equation. And for part A, they say when is the baseball at a height of 68 feet? Okay, so let's do that part first. So when is the height 68 feet? So we know height is 68. Height is 68. Where should I put that in my equation? Do you think that's h or do you think that's t? The height is h, okay? So they already told us that. It's height in feet is h. So I'm going to come down here. I'm going to put for part A, 68 equals, I'm going to write that out, negative 16t squared plus 80t plus 4. Now what should we do? Let's go and get everything to one side. Okay, so subtract 68 from both sides, and you'll get 0 equals negative 16t squared plus 80t. 4 minus that 68 would be a minus 64. Now let's go and factor. Remember, the first thing we want to do is try to see if there's a greatest common factor. That's going to make our life so much easier because I don't know about you, but I do not want to multiply 16 times 64. That does not sound like fun. So what I'm going to do is, I've worked ahead on this. Hopefully you have too. I actually found that I could pull out negative 16. Whenever you can, bring that negative out front so that it leaves your polynomial that you can hopefully factor, it leaves it positive. Okay, so then we have a t squared. Because if you didn't plot that negative 16, you'd have to put a negative here. That would not be a good idea. Okay, so we want to leave that part that we're going to factor positive. So t squared minus a 5t plus 4. So now we're going to factor. Leading coefficient is 1, so I can jump to the shortcut. And two numbers that multiply to 4, but add to negative 5, negative 4, and negative 1. That wouldn't make any sense if I said negative 16 equals 0, so I'm not even going to write it down. I'm just going to write down the other two here. So t minus 4 equals 0, t minus 1 equals 0, meaning that t is equal to 4, and t is equal to 1. So what do those numbers mean, t equals 4 and t equals 1? It said that's going to be the height of the ball. So the height is 68 feet after t seconds. So that's how many seconds. So we actually want to label that with our words, okay? Anytime you have a word problem, go ahead and label your answer. So 4 seconds and 1 second. Second part of question A says explain why there are 2 such times. Why do you think? Why is there 2 times? Can you think about that? You throw the ball up in the air and it hits 68 feet. Why is it hitting it 2 different times? Usually in class, I kind of mime this so it's easier to see. Here on my iPad, maybe I'll draw a little picture maybe. So here's me. I'm going to throw this ball up in the air. Okay, so the ball goes up, and then it hits, say if it hits 68 feet, say that's after 1 second, and I threw it so hard it just keeps going up, but then what happens? Then the ball has to come back down again, right? So then it hits 68 feet again, after 4 seconds. All right, hopefully that makes sense. Let's try part B. And again, if you struggled with this and if you didn't get part A, now would be a good time to go ahead and hit pause and try to do B and C, because they should be exactly the same. It's just plugging in 100 feet and 104. Okay, so hit pause and work on it. I'll go ahead and work on it while you're working on it. All right, so for part B, I plugged in 100, got everything to one side, factored out negative 16, factored what was left over, solved for 3 seconds and 2 seconds. All right, now I'm going to work through part C. All right, so hopefully you got the same thing. I plugged in the 104, moved everything over. This time, though, when I factored out my greatest common factor, I was left with a trinomial that had the leading coefficient greater than 1, right? So that meant that I had to break apart the middle term into 4 terms, use factor by grouping, and then finally I ended up with 5/2 seconds. And most of the time, I want you guys to keep everything in a fraction, but in a story problem, it's pretty typical to switch over to decimals just because it makes more sense to tell someone, yeah, I threw the ball and it hit 104 feet at 2.5 seconds, rather than, like, you wouldn't walk up to somebody and say, yeah, I threw the ball and it hit 104 feet at 5/2 seconds. That would just kind of sound weird. So in story problems, I'm okay with you switching over to decimals. So ends up being about 2.5. Some people don't know how to get it from the fraction to the decimal, and really all you have to do is on your calculator, just for that fraction bar means divide. So just do 5 divided by 2, you'll get that 2.5 seconds. All right, so now I think we just have one more problem. Okay, so if you didn't try it already, give it a try. So in this one, it says a rectangular garden has an area of 162 square feet. If the length is twice the width, find the dimensions of the garden. Okay, I don't know about you, but for me, I have to see a picture. Okay, otherwise that's just a jumbled up mess for me. So let me draw my garden. Oops. A rectangular garden. Okay, got it. Has an area, so that's the inside. Remember, I'm trying to remember, area equals length times width. Do you remember that? So the area of the inside is 162. You can write square feet or you can write feet squared. It's the exact same thing. 162 on the inside. And then we know that we have the width here. Now the length. Sometimes these words get kind of mixed up, right? So the length, so that's what I'm going to put as L, is, in math the word is means equals. So the length equals twice. What do you think twice means? 2, right? So length is twice the width. So if it's twice the width, how would I get twice the width? 2W. So L equals 2W. So the length is twice the width. So if area is equal to length times width, do I know what the area is? I do. It's 162 square feet, right? So 162 equals L. Do I have another way to write L? I do, because it said L equals 2W. So instead of writing L, I'm going to write 2W. And then finally, I still have this W left over, right? So now, all I've done is I rewrote area equals length times width with my area of 162, and my length is 2W, so that my equation now only has one variable that I have to solve for. Okay, so let's go ahead and simplify. I'm going to break this into a couple steps here, just so hopefully I don't lose you. Okay, so 162 equals 2WW. What could I write instead of WW? W squared. Now, I'm going to want to solve this. Okay, so I'm going to do minus 162 from both sides. So I get 0 equals 2W squared minus 162. First thing that we look for, is there a greatest common factor? There is. 2 goes into both of them. So we have 2 times the quantity, W squared, and this ends up being minus 81. Do you recognize W squared minus 81? A difference of squares. So that means we have 2 times W plus 9 times W minus 9. I go ahead and solve. If I did this W plus 9 equals 0, I'll get W equals negative 9. Does that make any sense to have a negative width? It doesn't, so I'm just not even going to worry about it. But over here, W minus 9 equals 0. This would mean that my width is 9 feet. Okay, and again, it's a story problem, so you want to label it. Am I done? A lot of people stop right there because they're like, well, I did all this work. I drew a picture, I had my formula, I plugged it in, I got an answer, and I'm all done. But if you go back and reread the problem, it says, if the length is twice the width, find the dimensions of the garden. We found one dimension, right? So they want us to find both of them. So now we have to figure out a way to find the length. Okay, so we know that the width is 9. How could we figure out what the length is? How about, let's take that 9 and let's plug it right in. Okay, so the length is 2 times W, and now we know that W is 9. So 2 times 9 is 18 feet. All right. Hopefully that wasn't too bad. This was our last section for this unit. So now we'll do our review exam and then we'll move on to the next unit. Awesome. Keep up the good work.